So it's October 1st. You've hopefully updated your note card. Starting tomorrow, we're going to start adding to this. By the end of this week, you're going to have 4 new equations on there. And we'll talk about keeping it simple so that you don't trip over your own feet. Any questions on 2A, 2B? Do you want to look over 2A, 2B with one another real quickly while I grab the quizzes? Okay, so I'm solving number 20 in the book. Here's what I'm given. A car heading in a straight line has a velocity of plus 5 meters per second after acceleration of 0.75 meters per second squared. The car's velocity is 8.0 meters per second. In what time interval did the acceleration occur? So you'll note that I have listed all my variables here. I have a VI of 5 meters per second. I have a VF of 8 meters per second, an acceleration of 0.75 meters per second, and I'm looking for the time interval. Because of the 4 variables that I have there, I looked at my note card and I decided to use acceleration equals VF minus VI over delta t. I knew I had to solve for delta t, so I rearranged and I got delta t equals A times the quantity VF minus VI. And I plugged in my numbers, and delta t equals 2.25 seconds. Anybody have any questions for me? So here's the point of the mistake game. Here's the point of the mistake game. I'm telling you, there's a mistake in there. Now, occasionally, and here's the thing that I find to be a nice layer of insulation for smart kids who are afraid to make mistakes, which I was for most of my life until I finally just embraced it. I've felt much better ever since. Sometimes, especially when we get into the really complicated problems, there's more than one mistake. They might not all be intentional. On these problems, you can pretty quickly figure out if they're right or not. You can come to agreement. As they get more and more complicated, people get more and more unclear about what the actual answer is and who's right. So the point of the game is that you are able to analyze a problem carefully and find errors, and that you learn how to do the following. Ask in gentle terms, because here's what you can't say. Hey, moron! You put in a negative, not a positive. What you can say is, was your acceleration given in the problem positive or negative? And if that's the mistake that they've included, the person in question will go, you got me. They gave me a negative acceleration, I put in a positive. Okay. So that's the kind of, we want to ask good constructive questions. So does anybody have any questions for me? Ms. Malcolm.
Can you show how you rearranged your original?
Oh, so you suspect there's an error there. Some of the rest of you may suspect there's an error there too. Well, let's see. I just moved delta t over here, and I did that. Would you like to ask a more pointed question? Maybe you'd like to ask a more directed question? That's how I did it. Do you want me to put on my other cap and ask myself questions? Oh, I have a question. I have a question. Yes, Ms. Moser. When you're rearranging and solving for something that's in the denominator, would you multiply both sides by the denominator? Yes, I would. Oh, wait. That's okay. It's just a nucleus. Yes, I would. Can you show me what that looks like? Sure. Let me get rid of this. Thank you. Oh, it looks like that. When you're solving for something that's being multiplied, would you divide both sides by the A? Yes, I would. Okay. Yeah, you were on to me. You were completely on to me. It's a really obvious mistake. Now, I can't do that anymore. That said, it's also the mistake that is most common. Solving for things in the denominator, people who are really good at algebra, people who are really smart critters, still make that mistake. Ask me how I know. 11 years of grading that mistake. So once I'm busted, then on the next slide, I'm going to have the correct solution, and I guess I didn't get it finished. Whoopsie. Copy that, paste that. There, good enough. Equals 8 minus 5 divided by 0.75. And I didn't. You should, when you're doing mistake game, you actually want to have the completed problem on the other side. So we have a delta t, an interval of 4 seconds, not 2.25. This is actually a tricky problem, and that would be a good mistake, because the answer that it gets you is not unreasonable. And if you're used to doing sort of a reasonableness check on your own papers, on tests and quizzes, so you look at it and you go, yeah, that's okay, that's not crazy. You look at this and you go, yeah, 2.25 seconds, that sounds reasonable. Well, it is, and it's not. I mean, it's, what, almost half the actual interval, but it's still not a crazy time interval. So that on its own doesn't help you find your error. Do you kind of feel like you have a sense of how to do a mistake game? So what I'm going to have you do now is every group has to do number 5. And every group should also do 2 other ones, and then we'll roller derby for the answers. And you're going to have 2 slides for each problem. So you'll have problem number 1, and you'll have your mistake. And then you'll have problem number 1 with your correct solution. So we're talking about 6 slides. I don't care if you do them on 3 different iPads, but then you'll be presenting, and I don't think everybody will get to present because we'll have to fight for the airplay. But everybody has to do 2 problems, plus everybody has to do number 5. Because that was the one that there was the most disagreement on, so I want to have you all argue that one. Yes, sir?